So once again, thanks everybody for coming. Really quickly, we are the company. The company is Yugabyte. We are the company behind the open source database called Yugabyte DB, which is a fully Postgres compatible but distributed database. So think you'll be able to scale out and grow and shrink as you like, but it's full Postgres on top, right? And why are we talking here in the AI, ML, and Vision meetup? It's because we are converging and building Postgres to fit AI needs. So, think Postgres for AI. That's really what we're trying to do. It's not just the Postgres portion of it. We have a vector store. It uses the pgvector interface, but performs really, really well, like in terms of its performance and capability. And we're also looking at putting in graphs, GraphRag, and a bunch of other things inside to make it very easy to build AI applications, right? So that's really what this talk is about. It's about how we go beyond just vector search and how a distributed Postgres database like Yugabyte DB can power applications that you start on your laptop and take it all the way to a enterprise-grade deployment anywhere you want. Okay, so all right. Yeah, I should have said all that on this slide. So just replay that in your mind. It's a Postgres-compatible distributed database, resilient and scalable, and it's the foundation, data foundation for AI workloads, right? So we're trying to put the AI into Postgres and make it a true next-generation AI database. All right, so how do we approach, what is our view of the world, right? So we come from the data side, different people are coming to AI from different points of view. Ours is a data-oriented view, right? So, and we feel that agentic AI applications, the data architecture is really hard, right? Because there's a lot of focus when you're building agents on the agent part. How do you build the app, the SDK, right? But not as much focus on the data part. And the data layer has become very complex. And if you want to run your own model, if you want to run an open weight model, if you want to run a standard deployment, but in a multi-region, in a different cloud, in a private cloud, run it on a smaller form factor box that you take closer, all of this is getting really, really hard. So if you take a very, very common framework, Crew AI, you could take anything, LangChain, LangGraph, any of these things. These just let you build agents, right? If you look at it, it does a lot of great stuff. It's really, really good, very, very powerful. But when you look at the data side of it, it's complicated, right? So it needs a SQLite database, which is the default. SQLite is an embedded database, so when it goes down, you don't have a way to make it resilient. It's complicated to get it resilient. Of course, it supports a host of databases that you can put its default stuff on. And when you're trying to run your reasoning, your models, you need to accelerate it with a cache, like a KDN. What do you do for that? You need a graph database, you need Postgres, a vector database, MCP server, some kinds of RAG pipeline with distributed processing, especially when you get into scalable scale needs, so on and so forth, right? So the picture gets very complicated. And so, yes, you can build it very quickly, you can build it on your laptop, but when you actually try to put it in production, AI is all about putting it and iterating quickly, right? That's really the name of the game. So when you try to do that, it gets very, very difficult to do so. The difficulty comes from you don't want to lose your ease of building. All these data models make it easier to build, but you don't want to lose a path to production, right? And what happens after you go to production is you have to be able to maintain your ability to iterate. Every experiment cannot get harder than the amount of time it takes to even get it in production in the first place, right? So these are some of the challenges that we start to look at. At a high level, this is what it looks like. There's the agentic app framework. There's a ton of them. And at the bottom, there's a ton of databases, right? And so each of them, there's a few layers of the stack, observability, there's the inference layer, the knowledge layer, and the storage layer, right? And when you try to put them all together, it gets hard. You got to piece all of these together, and each layer has a lot of complexity. So we will look at a little bit of what's in these layers so you guys have a little bit of a view of what happens under, like how the engine is built at the data layer side. But before that, let's just look really quickly at some of the challenges, okay? I'm going to breeze through it. Again, like Jimmy said, please rudely interrupt because the rest of us won't fall asleep. That's me included. So please feel free to ask questions. Okay. Agentic architecture today is got a lot of stuff. That's what it looks like underneath when you open up the data layer engine. That's what it looks like underneath, right? It looks a lot worse than that. That's a simplified version. So first thing is too many damn databases, right? You got to make sure every one of them is available and scalable, and you have observability, and you know what to do, and secure, and all that stuff, right? You got to have people that understand these databases, because if something doesn't work, you got to go tweak it. Second problem is you need a inferencing cache to speed up some of the operations, especially if you want to reduce your bill. Everybody likes to save money. Everybody likes money, so they don't want to keep paying for repeated operations on GPUs. So you want to make sure that that's more efficient. It's the next piece is you have a RAG pipeline, but does it really scale? Can you do 10 documents in the RAG pipeline? Can you do 1,000? Can you do 10,000? Can you just scale it as you need it when you need it? Are you doing repetitive work there? Are you able to customize it? Are you able to run experiments and quickly find out if it works, or is that a whole new rebuild, right? And then you want the people interacting with it. You want them to get the experience that what they're talking to actually remembers them. Not like I closed the session and came back and who the hell are you, right? So you don't want that to happen, right? And the knowledge base side where you're doing the indexing is completely cut off from the inferencing side. You need a little bit of overlap between the two. And lastly, you got to get all of this to work together, right? So if something doesn't work, it's not just what did my LLM do, it's everything. What query did my LLM fire to the database? What did my database do? What did something else do? So everything matters, right? So to get the real performance. So this is what we're trying to simplify. And we're building an open source project. Again, Yuga AI is just a template name. We'll change the name. We're still working on it. Too busy figuring out this stuff to come up with a name. But anyway, so it's a well-tuned data platform that simplifies these three layers: the inference, the knowledge, and the data layer. And each of it does stuff. You could take a look at it. The idea is, each of those layers is fast-moving. It has a lot of components. It does help with, there's a reason for it to be fast-moving and new components get introduced, but there's a stateful part to it that makes it very hard, right? And the idea is build quickly, like on your laptop, but then have a path to production anywhere. So don't have to worry about, oh yeah, this can go to this cloud, but not there, none of that stuff. And you should be able to deploy anywhere you want, like private, public, hybrid, multi-region, whatever have you, depending on your needs, right? It deploys a whole bunch of stuff. Again, I'm not going to bore you to death with the details. Like, do reach out to us if you want. There's a couple of demos, so I'm speeding up for that. Wrong side. Okay, so this is how we are unpacking it, okay? Remember this slide where we said all of that stuff, that's the hard stuff. So let's focus on the hard stuff. How are we simplifying the hard stuff, right? So first thing is you get unstructured data and data in the database, both flowing in, and you have to work with both of that data. You have to index it, you have to do stuff with it, right? So let's go from some of the layers. The first inferencing layer, you have the memory aspect, you have the runtime, you have your custom LLMs, and you have to speed it up with caches, right? Caching is a stateful component. It involves data. So that's one of the areas where we make it scalable and easy to work with. Second is the knowledge layer. You deal with MCP server, your sources of data, tracking them, understanding what really goes into the system so you know what comes out is only as good as what goes in, so you're able to track it, be able to index it in time, really quickly, in real time, and do some like improvement of the quality of data analysis, et cetera, right? And the database layer, you've got like your traditional database, a vector database, a cache, a search, and a graph, right? So you have all of these access patterns. Figuring out a separate database for each one of these, too much work. So we're trying to converge it into Postgres. So ultimately one database with different access patterns that will seamlessly integrate into the stack, right? So lastly, of course, you need to deal with observability, and increasingly I'm finding everybody calls everything observability, but there's like 15 things inside there. So you have to deal with that too, right? So ultimately you need to know, is it like you're proving to a security person that nobody did anything bad, or you're proving to a performance engineer that it is performing optimally? There are very different ways, right, like of thinking about observability. So I don't know, how many of you guys follow soccer? Okay, not that many. There's a very famous coach called Pep Guardiola, okay? And the reason to talk about soccer is the World Cup is coming to the US in a few months this year. So, we're going to be talking about, one of these coaches that's really good. We're going to be building an agentic version of this coach. So, I'm going to play this short video here.
Hello, everyone. I have downloaded the Yuga AI platform. We are about to get the platform up and running. Let me go ahead and do Yuga AI start. This is going to bring up a few things behind the scene, like it's going to start the Yugabyte DB database itself. Let's wait for the Yugabyte DB database to start up. Looks like the database is up. Now we are configuring the database for the platform. It's going to add the required extensions and create the tables that we need as part of the platform management. And also it will create a system agent for us. So this looks like the system agent is started, and the system agent UI is running in this URL. Let me go ahead and go to the UI. So we have a login page where we can use the default credentials for logging in. I can use Gigabyte and the default password for logging in, initializing the system agent. The agent is able to do a few things for us. Agent can like create a new agent, a new user agent, list all the agents, describe what the agent configurations looks like. Let's try to go and interact with the agent itself, right? Let's ask the agent, who are you, so that it can provide us what the capabilities that it has, like a help, right? So it says, I'm Yuga AI, I'm an AI data platform to simplify building agentic applications, right? And also we have some quick prompts that users can, whoever the user who is logged in, they can run. So we can try to see what are the key architecture components of the Yuga.ai look like. So we can see what are the key components that we have: the inference layer, the knowledge layer, and the database layer, right? Karthik already talked about some of these high-level architecture already, and this is just giving a few more details on that. Also, we can check what are the some of the key capabilities that the Yuga AI platform provides. So what are the different actions the users can take as part of the platform, right? So if you can see, it's going to provide a list of different capabilities that the system agent itself has. So it is able to do a few things like create an agent, deploy, create and deploy an agent, and create a knowledge base and vector index out of it. So now let's go and try to create our first agent, right? So we can click on new agent, or you can just converse with the system agent. So for now, we are going to create the new agent using the quick prompt that we have. Also, we wanted to do a soccer agent because the FIFA World Cup is right around the corner. We are going to call it pep.ai. And we have a few different LLM providers that we have: GPT, Llama, DeepSeek, Gemma, or any Hugging Face model that you might want to bring in from open source. We can use it as a LLM provider. For this demo, we are going to use GPT-4o. Let me click on GPT-4o and I'll do a create agent. What happens is, behind the scene, the platform is creating the tables and the databases, then the database for the pep.ai agent. As you can see, it gave out the URL to connect to that specific agent, and also a few other details like what is the YugaByteDB database that the agent will use, the graph database it will use, and you'll have all the other information like the connection string that you will need in your user agent for connecting to Yuga AI platform. As you can see, some of the other configuration is like what is the inference LLM provider, what is the embedding model that we'll be using, what is the vector store that we'll be using, and what are the graph store that we are using, right? This is the details that these are configuration details that you will be using for implementing your user agent. And also, we can go ahead and create a knowledge base as part of your agent. So let me, I have some knowledge base that is sitting in the S3 bucket. I want to load it. Let me go ahead and ask the agent to do that. So what happens is, behind the scene, we have a PG distrag extension that is available as part of the database, which will go ahead and start building the index for us. Once the build index is created, you will have that as part of a vector index where you can run similarity search against it. So now let's go ahead and see how the pep.ai agent will look like.
Okay, so that was building the data layer for the agent. So it's not building the actual agent. The agent you'll build through one of the agent SDKs, but this is building the entire data stack for the agent, right? So let's look at using pep.ai.
So hey everyone, this is the PEP AI, which was created using the credentials that was previously shown, that was created in the Yuga AI platform. So let me start by starting a training session for the player Messi. So this is initializing the AI coach. Here we are, and we can ask any questions to the coach. So I have a couple of prompts. Let me start. So I'm telling my coach that, okay, hey, my name is Messi. I play the right winger position and I'm a left-footed player. I have good dribbling skills and I want to improve on my weak foot and shot power. So here the LM is thinking and respond for response. Yeah. So we have a response from the LM. The LM has registered the player as the Messi, and he is suggesting some techniques or some drills to improve on the weak foot skills and shot power, as mentioned in the user prompt. These memories and this chart basically creates some memories, and that memory has been added to a memory store that was previously shown. So let me show the memories or the graph entities which were created in the database. So as you can see, the user ID Messi has been connected to weak foot skills, dribbling skills, right winger position, shot power, all the specifications that we have mentioned in the chart. So let's go and ask another question to the PEP AI. So I'm asking, based on my soccer preferences, can you suggest 15-30 minutes of training drills that I can practice daily? So this prompt will prompt the agent to use the memories which were previously stored as part of the response, as part of the chart that has already been done. So I have a response from the LM that remembers my position as the right winger, being left-footed, and want to improve on my weak foot skills and the shot power, while capitalizing on the good dribbling skills. So the response and the drills have been created according to that. I can also show that the memories were retrieved during this process, along with the scores which were given to each memory. So this basically shows that we have the memories were retrieved from the memory store. Let's go and ask another question. So, hey coach, I want to improve on my shooting accuracy and the passing skills also. So I'm adding more memory, I'm giving more context to the coach to get more specified or comprehensive drills. So here the LM has responded, okay, great, improving the shooting accuracy and passing skills, and the drills have been modified according to that. So let me go to the database and see if the new entities have been added or not. So I can see the shooting skills and passing skills have been added as part of the graph database. So this basically shows that each new memory, or as in when we chat with the agent, the memories get added and updated in the back database, which can be retrieved for future chat purposes to get more comprehensive answers. Yeah, that's it from my demo. Thank you.
Okay, so the idea is that this stack, like whatever you saw, like if you didn't have memory, right? Like if you joined, it would answer each time. Like in that session, it might remember you. You come back to the session, it's just wiped out. It's like the same answer that anybody asks. So this helps persist all of that. Like, and it does a lot more things, like how do you improve semantic relevance, so on and so forth. And the host of databases needed underneath there, like abstracted away. So this entire stack, you can just start with that simple command. You got .ai start on your laptop, get going. And the thing about Yugabyte being a distributed database, you can then, like, let's say everything's great, you want to go production, you want to make it highly available, whatever it is, you can start 2 other nodes and join the first node, and now you get a 3-node cluster that shares the context and behaves like one giant node of thrice the capacity, right? So, and let's say everything's going great and you want to even continue further, you can then add one more node and still have that join the cluster, and now you get even more, right? And of course, you can add and remove on the fly. You have node failures, you're fine. So it just makes it easy for you to take it from, what was a simple prototype, something you're iterating on, to going to, production grade. So it's an open source project, folks. So as Jimmy said, it's like something exciting for all of us to join. Anyone can, if you're interested, either for early access, to get involved, whatever it is, do reach out to us, info@yugabyte.com.